Hi, I'm Matt Conrad, host of the Reliability Matters podcast, and we are in the Global SMT studio here at Apex 2020 in San Diego. And today, my guest is Sal Sprancino, sales manager extraordinaire from Zestron. How are you, Sal?
Very well, thank you, Mike.
Raise the bar. Raise the bar.
You
I was going to call you the intergalactic sales manager, but I don't know if your territory goes out that far.
Not quite.
Not
Yeah.
yet. Well, thanks for joining me today in the global booth. I want to talk about cleaning, but from a chemical perspective. You know, I'm the equipment guy, right? And you're the folks that supply the juice that makes the whole process work. So my experience is more and more people who are deciding to clean are running a chemical additive. The most popular way to clean boards is with a water-based process.
Mm-hmm.
Solvents used to be extremely popular until they weren't. And now water-based processes, aqueous process, it seems to be the conventional wisdom right now. And your company and others provide chemicals for that purpose, to add to the water, to allow the water to remove things that water would not normally be able to remove.
Correct.
Right? To put it simply. So I'm a big proponent in using chemicals, even if the target contaminant, for example, water-soluble flux, is already soluble in water. I think there's a great advantage in running a chemical because not everything on the board is soluble in water, right? We think we're running a defluxing process, but we're really running a cleaning process. It's much broader than just one target. So if someone decides to use a chemical, we want to make sure we don't solve one problem, clean the boards well, and then create a slew of other problems. So whenever you say the word chemical or chemistry, you can just see exclamation marks go off in people's faces, right? And concern. What's the chemical? What's its nature? How does it interact with employees? Is it safe? What about the environment? So tell me how your company and really as an industry, how do these chemical companies that produce chemicals that can remove all the bad stuff from a circuit board go about making sure that it doesn't cause any more harm to the environment and to operators and things like that?
Yeah, that's a very, very broad question, Mike, so I have to think about where to start here.
Keep your answer down to less than 3 hours.
Less than 3 hours, okay. I think we're down to about 10 minutes. Now, certainly a very good question. I mean, you and I lived through Montreal Protocol, right? Back in the 80s, I mean, I was a young engineer working for...
Which was the ban on CFCs,
Ban
right?
on CFCs, right. The hole in the ozone layer and so on. And, how do we try to minimize that or mitigate that and, change the world for the better, basically for our generation and that of our children. So, essentially that was the genesis of Zestron way back in the early 90s. Being able to make a water-based cleaning agent that would be a replacement for some of the CFC, HCFC type of solvents that were most popularly or most commonly used back then. And so so start thinking about that. So what people were using in addition to those types of cleaners are IPA, as you well know. We both go into a lot of plants and you see a lot of IPA even to this day. And IPA essentially...
Folks, throw away those IPA bottles.
I know.
They're really terrible.
I know. I love some of your presentations where the way you highlight that, where like when you see all those things on people's benches and whatnot, you just got to get rid of it.
That goes.
But anyway, but the point is it's 100%, right? Volatile. And in terms of grams per liter, they're like 787 grams per liter. So it is a big contributor.
And we're talking about VOCs, right?
We're talking about VOCs, exactly right. And so whereas on the aqueous-based cleaning agents, in full concentrate, they're still around that number. However, you're going to use those in the 10% range or 15% range.
You're going to dilute it out, right?
Yeah, you're diluting it out, and so your CFCs drop to, or VOCs drop to, maybe 100 or thereabouts. So, I think what it is for the industry, it's a way of being a good steward for the environment, right?
Right.
And going back to your point about, why would you even use chemicals today? We both know that this industry has changed tremendously just in our lifetime. I mean, my wife likes to use the phrase that, she and I are technology immigrants, whereas our children are technology natives.
Right.
But just look
True.
at...
That's a great way to look at it.
God bless my wife. True. Yeah. But if you just look at pictures of printed circuit boards, right? Look at where they were 10, 15 years ago and look at where they are today. Which gets us back to your point. So, we're dealing with circuit boards that are extremely densely populated, stacked components. The distance between the components is so much narrower. So even if you're using water soluble, how are you getting the water in there just to solubilize,
Right.
that
Surface tension of water alone is
70
72 dynes or so, and then you throw a little chemical in it, and all of a sudden you're down to like 20-something dynes, right?
Exactly right. Exactly right. And
Skinny water. I call that skinny water.
I know
right?
you do. I know.
You got to get the water thin so it can get under those very low standoff components.
And then, as I've heard you speak so many times in a lot of the sessions I've attended with you, you talk about all the other things that we're cleaning in addition to just
the usual
flux
suspects.
residue. I
Yes.
love that. I love that
Usual
chart.
suspects.
So the mold release, or I don't know, fingerprints and different oils and so on and so forth. And so the idea of cleaning is, well, it gets back to what you and I were talking about this before this interview. Risk tolerance. It's another phrase that I'm going to take from you. I'm giving you credit for that.
Fair enough.
You as an OEM, let's say, or a CM that you're making parts for somebody, what is your risk tolerance? In other words, how long do you want that part, that device, that whatever to last in the marketplace, right?
Right.
Is it a class 1, a class 2, a class 3? We both know that the class 3 suppliers, they're going to clean. The military guys,
Yeah,
the
they're
space
required
guys,
to,
the medical,
right.
sure, they're absolutely going to clean. But look at today. We were talking about this before this interview, the Internet of Things, right? How many devices are out there that if they did fail, it may cause some disruption. Look at cars. Look at where we're going with the electric cars these days.
Cars can't fail right now.
No.
In fact, last year, or 2018, BMW had to recall thousands of their i3 models because a board shut down because it wasn't performing properly. So the software shut it down, right? Which meant the car shut down, which meant you stopped moving.
Right.
And everyone behind you continued to move, right? Very dangerous. And they announced to the press, to the mainstream press actually, quite surprisingly, that the reason for the recall was that one of the boards was insufficiently cleaned. And then they said by their tier 2 supplier. So they kind of threw their supplier under the bus. So their contract manufacturer didn't clean the board well. But that shut down the car.
Right.
And
right.
You talk about IoT. The interesting thing with IoT is most of the explosion of IoT is probably class 1, maybe at best class 2. Not so much class 3. Class 3 has already been integrated into electronics for a long time. So we're taking toothbrushes and footballs and smart meters and Ring doorbells and which are really kind of class 1.
Right.
If they fail, nobody dies.
Right.
So, except maybe the reputation of the company. And we're taking these things and sticking them in harsh environments. And they are failing. And they're not built to class 3 standards, so there's no requirement to clean. There's no SIR tests or ROSE test or any kind of quantification for cleanliness. They just put them out in their cheap devices, and they fail, like cheap devices fail. So cleaning now has, I've seen it move from the class 3 and maybe some class 2 to all 3 classes.
Right.
Because otherwise they don't work.
Right.
No one dies.
Right.
But they just don't work.
Right.
If contaminants are left on them.
Right.
So if someone's going to start a cleaning process, if all of a sudden the ghost of cleaning past, knocks on your door at midnight and wakes you up and says, you're going to be cleaning tomorrow, what do you recommend? Chicken and egg. Should a person look at a chemical? Should they look at a machine? Should they look at a process? How would you advise people to contemplate a cleaning process, and where do they start?
A really good question, and we would like, as a chemistry supplier, we would very much like to be involved from the very beginning. Meaning, somebody has a process. Maybe they weren't cleaning at all. Let's take your example. Maybe it's a class 2 supplier of different devices, and it was never thought about. So a number of things come to mind right away. What's the production cycle going to look like? Are they running, one shift a day? Or are they running, thousands of different? Are they running, thousands of boards? Or are all the boards the same? Are they like, low volume but high mix, or high volume low mix? Your company makes batch cleaners, and I've seen many of your presentations, and it's an ideal fit for many of the customers out there. It's probably one of the most widely used machines out there. There's also a lot of inline cleaners, right? So I think it just depends on, where's the customer in terms of their production cycle. So kind of think about that first, right? Now, as far as the cleaning chemistry goes, we always go right. The first place we're going to go is what types of solder paste and fluxes are they using? How many heat cycles are they going through? Is it a double-sided board? Are they doing selective solder? Wave, reflow. These are the types of questions we need to ask to understand, how challenging that defluxing process is going to be. One of the things that we like to do is bring people into, not to make this a commercial, but if you come to Zestron, we have lots of different machines there. People can, they can try the batch cleaner. They can really, analyze.
Make sure everything's compatible.
Exactly
as a
right.
Process.
Yeah, exactly right. So, so start with the process. If you go back to your question, start with the process, the production, what kind of cycle these guys are or the customer may be looking for. And then we look at the solder paste, the residues, and then, we can start narrowing down the window of different types of defluxing agents and, kind of, direct the customers
really
to where they
understand what
want
you're
to go.
removing.
Yeah, exactly right.
Understand what's on there, not just what you know to be on there, but other things you might not know to be on there.
Right, right.
We're starting to run out of time, but I do really want to ask this one last question. When I started in this cleaning industry in 1985, might as well be 1985, 35 years ago, cleaning agents were all super high pH, saponifiers, right? And they would run a saponification process. The high pH would react with the acids in the flux and convert it to soap, which could be rinsed off. And if you ran too long a cycle, your joints would come out black and tarnished and corroded. It was hot. It was what I call a hot chemical, right? And my understanding back then was, the higher the pH, the more effective the solution. And now, I think starting with your company and other companies I think have followed suit, now the concept of pH neutral, or at least very near neutral, is becoming more popular. And I've seen pH neutral products work well in a lot of applications. I'm assuming they're not for everybody, but I'm assuming when they work, they work. So what is driving the kind of the pH neutral craze, and what are the advantages, assuming it works, and not assuming it doesn't work, so assuming it's compatible with the soils, what's the advantage of running a pH neutral over a traditional high pH chemical?
I got you, and thanks for that question. A couple of things. Really, what you're getting at is solubility, right? So, you have to be able to reach the contaminant. You have to be able to solubilize that contaminant and be able to rinse it away as well. And as you said, historically, a lot of cleaning agents were very alkaline. 11 or 12 or thereabouts in the pH range, right? And then in the early days, nothing was inhibited also, right? And then components start to change,
corrosion inhibition agents weren't there in the early days.
Exactly right. And so then a lot of the alkaline cleaning products had, inhibition packages put into them, designed into them so that they were able to, clean sensitive components without stripping surfaces and things along those lines.
Aluminum, for example.
Aluminum anodides, exactly right. But now to your point, there's been a big push environmentally, right? It gets back to the Montreal Protocol in some aspect where, you're concerned about the environment, but not just the environment in this case, the person that's using the cleaning agent.
Right.
So a pH neutral cleaning agent, it's
micro and macro environments, right?
Exactly
Big
right.
Picture and
picture
smaller
right
in front of you. Right?
Exactly. So it's definitely more user friendly, and so on. So when we developed pH neutral cleaning agents, it was a fine balance to design it or formulate it in such a way where it has the solubility effect, to get back to your point, where you're able to solubilize those residues, an inhibition package, so that we're still not going to be causing any kind of corrosion or things like that, and also be able to maintain it in the pH range, which for us is somewhere less than 8. So usually in the mid 7s, maybe about pH of 8 or so.
7 being the neutral, right?
Yeah, 7 being by definition. Correct.
The target.
Right. And so, and then if you're a company that has environmental initiatives, take ISO 14000, for example. If you're an ISO company, that's a continuous improvement process with an environmental focus, right?
Sure.
And the pH neutral cleaning agents may allow you to avoid neutralization, for example. So it makes it a little bit easier for the processor to use it and eventually discard that pH neutral product. And as I said earlier, with the people that are using it, it's definitely more user friendly. It's not caustic, things like that. So it's been a very big driver for our company, and I think our first one came out in 2010, and we've had different versions or variations of that ever since. Basically reacting to the direction that the solder paste companies are going with the different fluxes and solder paste that they're making these days.
Sal, thanks for being my guest. I wish we had more time. We could talk for hours, as we normally do, just not always on camera. Thanks for being my guest today. And stick around after the break, because when we come back, we're going to be talking to Elizabeth Kidd of BTG Solutions about some pretty cool new technology she has with regard to knowing if your board will be successfully conformal coated or not. So stick around. We'll be right back. Welcome back. My next guest is Elizabeth Kidd. Elizabeth Kidd is the West Coast material scientist for BTG Laboratories. Elizabeth, it's always a pleasure to talk to you.
Likewise, Mike.
Yeah, thanks for joining me today. Thanks for being my next guest.
Oh, victim, yes.
Victim, yes. So, I was just talking to my last guest, who was a cleaning chemical supplier, and we were talking about the fact that more and more boards are getting cleaned today than ever before. And the most common flux removed from boards today is no clean, ironically. And there's a lot of reasons for that: miniaturization and boards going out into harsh environments and ECM concerns. So most people who are concerned about cleanliness of a circuit assembly is concerned from an ECM standpoint, right? Because they want to make sure they don't have a electrochemical migration failure, dendritic growth, or parasitic leakage, or anything like that. And one of the ways to postpone an ECM event it would be to conformal coat the board, because that limits the amount of moisture that can get to the board. And a lot of people have this, I like to consider it kind of a failed logic strategy of, we don't want to clean, so we're going to run no clean, and then to mitigate the risk of ECM, we're going to conformal coat over the no clean, and which is a little bit problematic, because the best practice for conformal coating is to make sure you have a clean surface. Best practice to paint a car is to make sure you have a clean surface. Best practice for any adhesion process is to make sure that the surface is adherable, right? So my knowledge, I looked through my knowledge base, and I can't remember if there's ever been a standard, conventional, popular method of testing for adherability. We seem to, the test for adherability seems to spray the coating on it and see if it comes off and delaminates over a certain amount of time. And although there are tests to quantify the amount of electrical resistance between 2 points or the amount of ionic contamination on a board, hasn't been, at least to my knowledge, a go-to test to determine if a conformal coating material will stick to a board. Then I met you last year or so. And tell me about the type of technology that your company has redirected to the electronic assembly industry. So I know you have a product that can determine the adherability, which I think is a Mike Conrad made-up word, but the adherability of a surface. So this table, will this table accept conformal coating or any other type of coating? What type of test has your company developed or capitalized on and built on, and how has that migration from that technology made its way into the electronics industry?
Sure, yeah. That's a great question. So I'm going to back up and comment on your test of adherability, right? Adhesion testing. That is the best way to determine whether or not something is going to stick, is to have a sacrificial coupon or have a witness coupon, or even to do testing on the coupons themselves that you're using in your manufacturing facility. Just do that mechanical test, spray on your conformal coating, do a little crosshatch test and a tape peel test, and just see, does it fail? And if it fails, how does it fail? At what force does it fail? Does it take a lot of force, or is it just flaking off, right? That's the best way to really get a good look at that. And we call that performance testing. What the industry and what a lot of industries have tried to do is to limit the amount of scrap that may be produced with this kind of adhesion testing. So they have tried to correlate methods like dyne testing and like water break tests to be able to predict the outcome of adhesion testing, right? Now, these methods, they've been used for a really long time, but they're not nearly as resolute, I think, as the industry is really needing at this point. You know, we're really driving towards a low scrap rate. We want really high reliability. And so what we ended up coming up with at BTG Labs is a mobile high-resolution test using water contact angle method. Now, this is a method that's been around for 100, 150 years. The fact that it has been introduced to a manufacturing facility is what is new.
And tell me about that test.
Yeah.
This is our target.
Yeah.
Okay.
Yeah.
You're going to take a drop of water and you're going to put it on this table, and something's going to happen to that water. What happens to that water?
Yeah, so the water is going to either spread out or it's going to beat up on itself, right? And so that
like a waxed
kind of,
car. If you wax a car and put water on it, you just get these giant water beads, right?
Exactly.
And maybe they'll roll off the car, but they won't tend to spread out and go together.
Exactly.
Right? Same thing.
Or like a Rain-X coated windshield or a Teflon coated pan, right? If you put something on that surface, like a coating like that, and you put the droplet onto the surface, you'll see it beat up on itself because it's not attracted to that surface, it's much more attracted to itself. That means that you've got the presence of some kind of hydrophobic coating, and for cleanliness, that may mean you've got something like a contaminant. You've got something dirty on that surface, right? Whereas, let's say you, and don't ever do this to your car, but for this example here, let's say you strip that wax off, you strip off the paint, and you start abrading into the metal that's underneath. If you then put a water droplet on that surface, that droplet's probably going to wet out a whole lot because what you've done is you've created a very reactive metal surface and it's probably very clean. So that's something that you would want to stick to, like you said.
I'll take your word for that. I won't try it. So a greater spread is not always a guarantee of success.
No.
On across all materials. On
No.
some materials it is, on some materials maybe not.
Exactly.
So how do we discern which materials and which type of reaction to the water bead go together?
Yeah, so we do this individually for each manufacturer that we work with. We take a look at the material system, and you've got to decide based on your chemical knowledge of the material, right? Is it a polymer? Is it a composite? Is it a metallic? What kind of material is it in those different classes of materials? And then you've got to push the needle around, right? You've got to do the testing. You've got to create a circumstance where you've got a nice low contact angle, and then coat that surface, do your adhesion testing, see how it performs. And then, of course, you'll do that for the middle range of contact angles. You'll do that for the high range of contact angles. And the adhesion performance testing is going to speak for itself, right? So in the case of like a polymer, let's say you over-treat it, right? Let's say you've got a plasma treatment process, or you've got a corona treatment, or a flame treatment process that you're using. You may damage that polymer, and the contact angle may be super low, and you may think, oh, wow, that's great. I've gone as low as I possibly can. Let's bond it up. It's good to go. And you may get the worst performance that the entire test shows.
The methodology sounds very familiar to the new IPCJ standard, Amendment 1 of Section 8, which changed the way boards are tested for cleanliness. It used to be you had to get a number on a certain type of test, a ROSE test. You had to get less than 10. Your 9.9 was, hey, ship it, it's good. 10 is fail, right?
Sure.
And now they've changed it, so you have to have objective evidence. Now there is no pass-fail number. They use ROSE and SIR, but basically you have to run the board under very stressful conditions in heat and humidity, under a bias, have it not fail, and then test what the SIR and ROSE test numbers are, and that is your number. So it could be different. You could have a different number than they can have, right? So it sounds like, in a similar manner, the pass-fail criteria is subject to objective evidence. In your case, does the material delaminate, if that's what your concern is? And if it doesn't delaminate, what was the contact angle that led to the successful application and the lack of delaminations, right? So you kind of back into the number as opposed to just say, if you're doing this, you need to get an 8. I don't know what the scale is, but an 8 or whatever. So in the electronics world, I understand that philosophy because your company provides equipment for a variety of different surfaces to a variety of different industries. Within the electronics world, though, if someone's running like a standard FR4 laminate, is there enough data in your company's brain trust to say, oh yeah, if you're running this laminate, running that conformal coating material, then here's what we recommend? Or is it still subject to objective evidence and qualifying it? Is it still individualized?
It's very individualized, right? So we can speak to ideal scenarios. We know the surface energy of an epoxy. We know its affinity for an acrylic-based conformal coating. And we know that if we've got a nice clean surface, we can get that to stick pretty well, right? The trouble comes when we don't have ideal scenarios in the manufacturing environment. When
that never happens.
Never happens,
never
right?
Happens.
When we start introducing variables from the supplier chain, right? We introduce contaminants from upstream before we even get into the assembly process. And then within the assembly process itself, there may be many times that a board is handled. There may be there may be materials that can transfer some of the worst things onto a board to prevent good coating adhesion, right? And that's unique to every manufacturing environment. So qualifying each, we call those critical control points. Critical control points. Qualifying those for each individual manufacturer is an absolute must.
Right. We always recommend when one's doing cleanliness testing for whatever purpose, that it's done at the very last step, seconds before conformal coating, if conformal coating is going to be done. Don't do it early in the process. If there's any more handling, if there's any more secondary or multiple processes or thermal excursions in particular, wait until the very end, test it at the end. I assume the same applies, even more so with your type of technology. You want to test it at the very last second, right?
Absolutely, absolutely.
So you see the worst of it rather than the best of it.
Yes.
So this tool kind of looks like something like a big barcode scanner, as I recall. Is that about a fair description of it, the portable tool?
Yeah, it's just a little handheld device that is in your pocket.
And it automatically injects some water on the surface, and then it has some kind of camera technology to see how the spread goes, and it can quantify that spread, and then it can be programmed to give a pass-fail, or does it give a range, or does it tell a person how close to the edge of the envelope they are, or does it just go, green, red?
Yeah, so we can do both, right? The tool, after, of course, we've done all of this testing, the adhesion testing, we've honed in on a range of contact angles that's going to give us the desired performance. We've tuned in the manufacturing line to give us what we need, right? We can then have pass-fail limits on the instrument that any operator can use to make sure that you're good day to day. We can also have a yellow line that pops up that says you're nearing the threshold of potentially poor performance. Beware. And it's simple as that.
Cool. So although this is relatively new in the electronics space, this technology, your technology specifically, has been in use for some time in other applications, right? Metal finishing and painting and things
Aerospace.
like aerospace. We only have a few seconds left, so let's wrap up with what right now, what applications are using this type of technology successfully that are kind of around our industry.
Sure.
Like aerospace.
Yeah. So heavy use in aerospace. That's really where we got our start.
And what are they concerned about? What are they testing for?
They're testing for the cleanliness or the preparedness of a composite surface prior to adhesive bonding.
Okay, so it's for adhesive purposes.
For adhesive bonding purposes, right.
And
also aerospace for coating applications as well.
In the building of those airplanes and the carbon fiber and all that, where they put layer over layer, is that an acceptable use of that technology to determine the adhesion of the next layer of carbon fiber, if I'm describing that correctly?
So the application is more for the end use, the building
Okay.
of the cured composite when it's been cured into the shape that it's going to end up being on the actual airplane itself. Yeah.
Okay.
Yeah. So
All
less
right.
so for the layup and more so for the end use of the
End
final
use.
product.
All right.
Yeah.
And how, so far, would you say the electronics industry is embracing the concept of being able to test for adherability of conformal coating? Are you getting some good traction on that concept?
Yeah. So, we've had some interest in being able to control supplier chains, folks who are, in the R&D process, and they're picking which vendor they want to end up transitioning to M&P, which is great, it seems to be being accepted well.
Excellent.
Yeah.
Thank you for joining me today, Elizabeth.
Yeah, thanks
I
for the
always
invite,
enjoy
Mike.
talking to you. I think that is a great new technology. I think it has a lot of really practical application in our industry,
Yeah.
and particularly now with IoT and everything going into harsh environments, conformal coating is really in a higher demand now. Automotive is driving that forward as well, and of course, conformal coating, which is designed to add reliability, is no good if the tool to add the reliability doesn't work, right? So if it delaminates, if it fails. So thanks for bringing that into our industry, and thanks for being my guest, and thank you to our viewers. Thanks to Trevor and his team for allowing me to invade his space in the global SMT booth, and I wish you all well. Thanks for joining us.